allows me to see that I have nothing more than this. Is that a -1 over s times epsilon? Is that going to give me this? Is that going to give me the negative SA minus A epsilon? Is that going to be a minus e to the negative SA? Oh my goodness. Plugging A in for t, doesn't that give me s times A? My apologies. I told you I'm very tired. Watch my P's and Q's. But you guys, is it not true? You guys, let's see if I can skip a couple steps. Dan, is that okay?
I think you just plugged in the wrong thing. I'm just plugging in A, like for the upper bound of A plus epsilon, plugging in for t.
Oh, I made two mistakes. So let's see. Plugging this in for t, I got my negative SA, got it. That's my negative s epsilon. Jeepers. And on the other one, I've got my negative s times this value of t. Better. You guys, can I skip a couple math d steps? I think I can rewrite this in e to that power times e to this power. Both these terms have a common factor of e to the negative SA. So can I just pull it outside? And I think the only thing remaining standing is a 1 minus e to the negative SE? Or epsilon, I keep saying e.
It would be negative.
You know, you're right. It's just I already had a negative sign up front, so I swapped it. Just to make my life easier. And if you guys take a peek at what the heck I have up here, I think it has nothing to do with that limit. So if you guys don't mind, I'm going to pull it out. I'm also going to pull out the 1 over s. And I think the only thing remaining standing is the limit as epsilon plays this game of the ratio of 1 minus e to the negative s epsilon over, oh, there's my epsilon. Now, if I do take a break and try to evaluate the limit, you know what, you guys? I get 0 over 0. That's beautiful. Now, I think I can apply L'Hopital's rule. When I apply L'Hopital's rule, let's give me this. Is that e to the negative as times 1 over s times the limit as epsilon plays this game. And you guys, I don't know what's left over. Is that going to be a, So is that a negative or positive s? Times e to the negative s epsilon over positive 1. And now pulling out my factor of s. I don't know, you guys, what do you think's next? Should I apply L'Hopital's rule again? Well, no, just evaluate the limit. I think this thing right here is just going to go to get positive 1. And that being the case, I think I'm left with, oh, check that out. That must be the positive direct delta function. So if I've got a mechanical system, sorry, any kind of system, in which there's an immediate unit impulse, then I know I have a boss.
You didn't even know what the function was.
I know. But at least, well, you know what? I did do something. I described the direct delta function as a limit as epsilon goes to 0 of this function. That is not uncommon in mathematics. Again, I refer to that as a generalized function.
Question.
Yes, Chris.
How is it that the Dirac delta function was 0 everywhere except for when t equals a, but it still managed to have an improper interval of 1?
Because that's the way I defined it.
But
Now be careful. It's easy. When you said delta t minus a is equal to 0, for all values of t not equal to a, that doesn't translate though into the limit of this particular function as epsilon goes to 0.
right. Yeah. But it's just hard visualizing that.
I know. That's why it's a difficult concept to put together. That's why I drew the funky little pictures first. Because I do think it's a very complicated in that sense. You guys, can I take time on the clock? Can we just solve a DE with this?
What about
Just your take-home quiz.
I got an offer for the quiz.
What's that?
You give me 10 points on the quiz and I will sing "Oh Calculus" in front of the class. A full show.
Brad, take my 10 points.
Yep, I can record
Brad can
it.
take it.
That is very brave of you, because I wouldn't have done it for 10 points. You guys could have just started. Just start the DE,
Yeah.
and we don't have to finish. I made up an example. Yes, I did. So, if I take a peek at this DE, only because I know how to Laplace direct out the function at this point, I think Laplace on the left-hand side leaves you with this. That'd be an s squared minus 3s minus 4 times Laplace of y. You guys, what did I just miss? I think I missed minus s times y of 0. Minus y prime of 0. And then you have plus 3 times y of 0. Is equal to the Laplace of the Dirac delta function. However, that leaves you with an s squared minus 3s minus 4 times the Laplace of y being equal to, I have no idea, is that an s minus 3? But I'm adding to that the Laplace of Dirac delta function, but that's just going to give me a factor of e to the, well, a is equal to 1, so e to the negative as is going to be negative s. And now, dividing both sides by the coefficient of Laplace of y, I think I'm left with this. So you guys, if you want more time for the quiz, do you think we could just talk about inverse Laplace? Well, let's not do it over here, because that's just a 100% piece of cake, isn't it? You're just going to use partial fraction decomposition. Here, you're going to use a bit more partial fraction decomposition, but because of this exponential factor, when I actually inverse Laplace, what's going to happen? I'm going to have to use the second shifting function, and I'm going to get a unit step function in the solution as DE, which makes a lot of sense. Because I've got y as my solution being something until all of a sudden I hit the time where t is equal to 1, I had that unit impulse, and I think my solution is going to change. And it's going to affect the change for the entire rest of the function for values of t of 1 on up. And so I think it makes a lot of sense that I introduce this factor so that when I inverse Laplace, I do use that unit step function. Did you guys see it? But we've already talked about that, so I think it'd be okay to stop with the solution at this point. All right, if you want that much time for the quiz. Oh, here it is.
Can you give us homework before we take the quiz?
Oh, yes, I can. Yeah, I'm still meeting on Saturday. I'll be here. I will. Yeah, I didn't get to the convolution interval, you guys.
Did I download it? No.
So you guys ready?
I've got it on my gameplay list though.
Section 8.3.
This is any good?
1 through 9 on.
Just a second.
Did you ever give 8.2?
Probably not. I'm not going to. We used it everywhere else. And at 8.9,
You said 1 through 9 odd for 8.3?
yes. Well, I think I just misspoke. And then it's section 8.8. 8.8. Just take a peek at 1 through, how about 11 on? Oh, I'm a mess, aren't I?
Just 8.3 and 8.8?
Yeah, that's it.
Are we going to do 8.4 and 8.9?
you guys, can I sneak in the 8.9 next time? I really meant to talk
Yeah.
about it today. What is
But-
8.4?
I don't know, I don't think we've done, or was it 8.4 that we didn't do, or was it 8.2 we didn't do? Yeah,
Skipping
but
that.
we skipped
Yeah, do you
8.2.
mind if I talked about it today,
Okay.
functions of exponential order.
Okay,
It's just, there's not much to do there.
okay.
I can ask silly questions like, is this function of exponential order?